Today we're going to talk about some applications of radical equations, and specifically the Pythagorean theorem. Way back in the day of mathematics, a man named Pythagoras did some investigating of right triangles, and just for notation purposes, here's a right triangle. It has a right angle notated by this little box in the corner. Side opposite that right angle is called a hypotenuse. The other two sides are called sides. We don't really call the hypotenuse a side. We call it the hypotenuse. It has its own special name. These two we call sides. Pythagorean found that in a right triangle, and notice, only a right triangle will this work for, the sum of the squares of the sides is equal to the square of the hypotenuse. So in other words, a squared, which is one side, plus b squared, which is another side, is equal to the hypotenuse squared. So that means if I have two sides of a right triangle, I can find the hypotenuse by using Pythagorean's theorem. If I take 3, square it, add it to 7, and square that, I'll get whatever my hypotenuse squared is. So this is 9 plus 49 will equal my hypotenuse squared. This is a total of 58, and that's equal to the hypotenuse squared. If I square root both sides, we get the square root of 58 is equal to the hypotenuse. Now there are no perfect squares in 58, so that's simplified as far as an exact value goes. If I wanted to plug that into the calculator, I get 7.6. It's important to know the difference between an exact value, and that's something in radical form, and an approximate value, which is something in decimal form. So now we're going to once again find the missing measure of the triangle. Again, we notice we have a side missing that's opposite the right angle, so again that's the hypotenuse. So if I take 2 squared, add it to 6 squared, I'll get the hypotenuse squared. This is really no different than the last problem. The orientation of the triangle is just a little different. So I have 4 plus 36 is equal to the hypotenuse squared. So 40 is equal to, I'm just going to call it h squared. Square root both sides. I get the square root of 40 is equal to square root of h squared is just h. Notice, again, this is the exact value here, but it's not simplified. So I break that down into 4 times 10, which is the square root of 40, or 2 root 10. Once again, this is exact value. If I wanted the approximate value, I'd go ahead and take the square root of 40, which is about 6.3 if I round to the 10th, is equal to h. And that again is an approximate value. So it's also said that if the sum of the squares of the sides is equal to the square of the hypotenuse, we can say that if a triangle has sides such that the longest side squared equals the sum of the squares of the other two sides, it's a right triangle. So it's kind of saying it backwards. Now, I'm giving you some numbers here, and I want to know if these are sides of a right triangle. It's always true that the hypotenuse will be the longest side, so we're going to say this is our h and this is our h. If it's a right triangle, then Pythagorean's theorem will work. So 10 squared plus 20 squared should equal 30 squared. Well, let's find out. 10 squared is 100. 20 squared is 400. And 30 squared is 900. Notice 100 plus 400 does not equal 900. Therefore, this is not a right triangle. Likewise, in this example, 16 squared plus 30 squared should equal 34 squared if this is a right triangle. 16 squared is 256. 30 squared, once again, we said was 900. And 34 squared is 1,156. So now notice 900 plus 256 is 1,056. That's equal to 1,056. Therefore, this is a right triangle. Now, if three sides have counting number lengths and form a right triangle, those measures are said to be Pythagorean triples. There are some commonly used ones. Most often seen is 3, 4, 5. Also 5, 12, 13, 8, 15, 17, 7, 24, 25, and 12, 35, 37. These are some of the most common that you'll see. So if you were to take and actually memorize these, you wouldn't have to work out those problems. Now, it's also true that any multiple of these is a Pythagorean triple. So we said 3, 4, 5 is a triple. Well, if I multiply all those by 3 and get 9, 12, 15, that's also a triple because I've got 9 squared, 12 squared, 15 squared, which is 81, 144, and 225, and those will all work. Let's do an application. We see that a computer monitor is listed as being 19 inches. Now, whether you know it or not, the distance of a screen is measured on the diagonal. So what they're saying is that we have a 19-inch diagonal. If the screen measures 10 in height, they want to know what's the width of the screen. TVs are typically rectangles, so we have a right triangle, and we're looking for an unknown side. Now in this case, we aren't trying to find the hypotenuse, we already have it. So we have the hypotenuse squared of 19 is equal to 10 squared plus this unknown width. We'll call it x squared. So if I take 19 and square it, I end up with 361. 10 squared we know is 100, and that's equal to, and that's added to x squared. Subtract 100 from both sides, and I get 261 is equal to x squared. If I want to get x by itself, square root both sides, and I get the square root of 261 is equal to x. Turns out that 9 actually goes into 261 a total of 29 times. So I can simplify this to an exact value of 3 root 29. If I wanted to just take 261 and find the square root of that, that would equal 16.24, and they wanted us to round to the nearest inch, which is 16. Again, this is exact, this is approximate, and this is rounded. That's all we have. Write your lesson summary, solve the questions below, and we'll get back to you tomorrow.